All right. Well, I don't believe this myself, but here we are. It's finally finished. I finally managed to refactor the entire code of my add-on exporter for Blender. My exporter add-on is finally rewritten. It is much cleaner, and it is surprisingly faster than before. I've done a few optimizations and I actually fixed a bunch of errors, but right now the whole animated level parts is completely disabled because I don't remember if I made a video about it. It's been a long time, but one of the problems with the animated level parts is that I actually had to handwrite the transform because the exporter was doing something wrong, right? And I knew what the problem was, but I think I mentioned that I had to rewrite a lot of shit to actually be capable of writing the correct information without going insane with the fucking tuple hell I had made with my code, right? So I did not fix the tuple hell because actually tuples are the fastest way to transfer data in Python, but here we are. Now you may say, well, this looks just the same as always, right? And it collides just the same as always. And I would say, yeah, pretty much. But I fixed a lot of things. So first of all, the exporter is faster than before. That's because now it caches information. So as you can see, the default texture used for everything is just the green grass thingy, right? And before, I don't know why I didn't think of this before, but basically it would always load the effect file from your hard drive every time it found a new mesh that required this texture, right? Now, since every single effect is identified under a single file, right, that contains all of the code for one single material effect type, they basically use the effect file name as an entry key in a dictionary, and it basically checks if you have already loaded this file or not. And this shaves off like an entire second from the export process because you don't have to go checking the hard drive to copy paste the same information over and over again. If you have already found this material, you're just gonna cache the information and keep it inside, right? I also, well, you can see now that the fires are looking a little bit weird. They are moving in directions now, and before they didn't. That's because I actually had the wrong vector for the direction vector, and I fixed that as well. Right now you can position orient your effects as well, and that's good. Sadly, that means that some of the effects that we had before don't seem to be on screen anymore. I just realized that. I'll have to fix those on the level editor. What else did we change? Oh yeah, the normals and tangents from the meshes are actually, they were wrongly calculated. After refactoring and changing some stuff from the code, I actually forgot to fix this problem because before I just did something dirty where I would just pick the points and calculate, the movement of the points and then like get the straight line out of that vector, and I would calculate for every single normal. I would have would place a point on the quote-unquote 000 location, and then I would just use the normal vector value itself as another point, right? Because think about the fact that vectors that are normals and tangents, they represent directions. They don't represent points. So when you use a transform matrix on it, you want to rotate it, you want to scale it, etc., but you don't want to translate the point, right? So first what I did was just remove the transform entirely. The translate component entirely from the transform matrix and just rotate it and scale the vector, and this works somewhat okay for orthonormal and bases and stuff, but like in some situations it gave the wrong result, and you can see it here. Look at that thing, it's got a shadow in there. Like I think we didn't have this before. It just looks better, right? Like the flat faces, they are much more recognizable now because the normals are actually properly calculated now, right? And During the refactoring process, I went with a very dirty solution, which was what I was explaining, which is taking the 0, 0, 0, then taking the normal as another point, rotating both of them as points with the regular transform matrix, and then calculating the endpoint minus the starting point to get, you know, the actual vector, and that way you would get the correct values, but that's slow. So the way that I do it now is the logical way that I should have done from the beginning, but I don't know why I didn't do this shit before, which is using the inverse transpose matrix, because in computer graphics, you know, when you actually want to rotate a directional vector, what I just explained with the points is 100% correct, but the equivalent and faster operation is to actually calculate the inverse of the matrix and the transpose. And you can look up online if you are interested in understanding why that works, but basically you gotta check how the planes where the normal is located would be resulting when doing that operation. So basically it's faster now. It's faster now, and it gets the correct result for the tangents and the normals. And look at this shit. It looks gorgeous, even though it's using the default materials. The shadows are even better now. Like, everything's cool, right? And the next step would be, you know, figuring out why the fuck my effects are not spawning everywhere. This thing still works and doesn't crash, right? And if I try to walk over it, I probably can still, yeah, yep. And if I do like this, I can probably sink and die, yep. And if we restart, it all works, yeah. That's pretty nice. The triggers, I think I broke them, by the way. Oh, no, yeah, it's working still. It's the particle that doesn't appear on screen for some reason. I'll have to figure out that one. But the triggers seem to still be working. If I restart this thing and come from this side. Oh no, the triggers are broken indeed, yeah. Because I changed the way the transforms work, and I changed that to actually allow animated level parts to work. So I'll need to figure out what the fuck I did wrong, but yeah, everything else seems to be working pretty nicely. And the collision system is also unified now between animated level parts and regular static level parts. So now they use all the same channel system. If we go into the editor, it's pretty dirty. It's not complete yet, but we can, you know, pick apart. And rather than having the different layers, since we ended up figuring out what the fuck each layer does, we actually have this. And I don't remember if I actually talked about it, but yeah, I think I did in the previous video. But basically, every single one of the numbers that corresponds to one of the layers, 0 through 9, you remember how there were 10 layers? Well, basically they correspond one-to-one with the collision byte enum used in the animated level part collisions. I don't know why they were separated. I get a rough idea implementation wise, but like, here we are. Everything is now you know, in common. Like, you can just, it's unified, and rather than using those channels, since there are only 10 channels, we could keep the number and have some kind of description of them, but I prefer having it as an enum so that it's clearer what the fuck you're doing, right? Like, you just pick this thing and we can go ahead and pick the floor and say, well, I want this to be grass now, right? Rather than being generic, and it would just work. Like, that's, how cool is that? How cool is that? That's pretty fucking nice, I think. Now, the only problem, as I said, is figuring out why things are wrong for these particles and stuff. But that's okay. We'll figure it out eventually. Probably because the vector, I need to change it for one that fits the particles, because as I said that I fixed the vector, but what I did actually is unified. So maybe, probably, it's not really like the same vector in all situations, but we'll see how to get things working again. I'll continue making another video and keep you all posted, because this is big. But for the rest of the video, we're gonna talk a little bit about this. Oh, actually, let me remember this. I need to go back to line 2.3k because there's actually a mistake here that I need to fix. Let me place a note in here. You can see my notes in here, like, get rid of the name tuples. Yeah, that's a funny story. Like, I was making the whole fucking name tuple system because I thought it would make things better, but it fucking didn't, because I had, like, read online that name tuples were going to be faster. Like, not faster, they were going to be easier to deal with because you didn't have to remember all of the members and extract them through numbers or through the tuple extraction system in Python. You could just use the name access. And just creating, like, not even accessing members, creating a name tuple added 6 seconds of overhead to the entire exporter program. Like, that's slow as fuck, right? And this is like over Python 3.7 or whatever the fuck, I don't know. Like, this is a point where it's supposedly been like over 4 or 5 years or whatever since the name tuples were supposedly made to be fast in an update, right? Like, what the fuck is going on? That was really disappointing. I'm not an expert in this, but yeah, name tuples are fucking slow. So I just went back to regular tuples, sadly. And yeah, it was kind of a delirious fucking set of comments. I'm sorry about that, but yeah. Anyway, let me just write to do go back to line 2.3 or 2350 to fix the fucking phone collision enable what the fuck thing broken, please. We'll remember about that later. Table description that I just wrote, but let's go quickly over the code because, well, I'm not going to look at everything, but we can get a rough idea of what is going on. And yes, I know, I converted to the charge of VS Code. I didn't really convert to the charge of VS Code. I still use Notepad++ and other text editors. I don't really like this one that much, but it's not bad. Like, it's really good actually, and it supports something out of the box without me having to define a custom language, unlike Notepad++, which is regions, right? And since I try to make, you know, the code go in different functions and different files and have modules and stuff to make it easier to work with, but I found out that they are actually fucking slow. So I had to scrap the entire idea of using modules in Python for the add-on, because apparently, even though they are cached in some binary files and shit, they are still slow as fuck. They are really, really, really slow. Like, they add an entire second of overhead to the export process, even though they are supposed to be in the PyCatch files, right? So it doesn't make much sense to me. I mean, I know that for most things it doesn't really matter because the slowdown of the module is like at startup, right? And you're like, oh, okay, you're just loading the files. It's like when you add multiple files and maybe a few compilation units in C, you don't care about waiting there 10 seconds compiling your files, right? Because the slowdown is at compile time, not at runtime, right? But here it is at fucking runtime, so we can't deal with this shit. So let me just go ahead and show the changes that I made. Basically, we moved a lot of stuff out here. We actually now have a few classes which I don't like, but I mostly use them as bundles of data, as you can see, and they are basically just that. Like, they are classes because I create like 2 or 3 of these guys over the entire process, so I didn't think it was worth it using tuples for that. It was far easier to just use something that let me access fucking members through name, right? So yeah, that's basically the only reason they exist. And this is to find scene data, and these are for generated scene data for the animated and static parts, right? So let me go over, well, we got a bunch of utility functions, object utility functions, which is where my problem comes from, right? This get orientation vector right here, I unified it for both the animated level parts, or what? No, I was talking about particles and something else. I don't remember what was the other thing that used this vector actually. There's something else that used it, and I don't remember what the fuck it was. Probably triggers? Yeah, trigger, I think. Maybe. And lights, yeah, that's right. It's lights and particles. They are the ones that use this thing. So yeah, they work correctly for lights though. But yeah, um, I don't remember why the fuck get transform data returns the orientation. This is a legacy thing actually, but it is what it is. That's kind of weird. I don't remember why I coded it like this, but anyway, let's go over the code. So basically, we got this class right here, which is the main exporter class, right? And it's got a fucking retarded execute method that literally just calls export data, and it passes the context variable, but it never uses it. Why? Legacy reasons. I could just remove it right now, but I don't remember why I passed it, so I'm keeping it there just in case I ever remember, oh, that's right, that's the reason I did it. I should probably check my first backup of the code where it probably is still reading in there. But yeah, we start the export process by using this generator class. Like the entire get, generate, and make stages of the process are completely opaque now. They are encapsulated within the processing data method from the generator instance. And the reason we're instancing things here is so that, you know, just like before we generated buffers of data within this export function, right? It became kind of dirty passing around data within functions and stuff, so I thought it would be easier to just have a class that uses some kind of local member and we access it quote unquote globally from functions without giving a fuck about the locality or carrying it and dragging it through functions, which, you know, goes against part of my philosophy considering I'm a C guy. But usually for that kind of stuff, when I have to carry lots of data, I use a pointer to some struct that contains some context with all of that data that I want to be able to access fucking anywhere, right? Basically what you do when you pass a this pointer internally in a class in C++, right? Like the fastest fucking way to do things and the most efficient one. But sadly, in this situation, we don't have structs the way that they exist in C. So what do? We use classes. Yeah, it sucks, but I will probably repurpose a lot of this code to actually use classes as structs and pass them as context references, I guess, and operate over them, because I find operating over classes as if they were just bundles of data much easier and intuitive. But that's just me because I'm mostly a C programmer, so anything weird with classes just feels like it makes me go insane, like the whole C# side of the fucking code. But C# is actually pretty nice, surprisingly, right? After generating all of the data, we simply just go ahead and do the whole fucking JSON writing process, and that's it. Like literally that's all it does, right? And the rest of the code, like, it's no longer here. We have the config, we have more config here, but we don't have anything else. And where's that code gone? Well, it's inside of the data generator class. And then we go over to the data generator. We got a bunch of regions. We got its constructor stuff, right? It just generates a bunch of dictionaries. This is the dictionary for the effects. This is what I mentioned before, where we go caching the materials as we create them, right? And we have this whole shared resources operations. You know, we can add the shared resources, we can make it into a list, blah blah blah. We got this whole stuff to make materials. This is where the whole caching process is, where you check if it's in the dictionary or not before adding it, right? This is where the things get interesting, right? So if we go over to the public methods, we got this one, which does literally everything that we used to do before in the other method, but here. And I will probably just extract all of this and write it manually because it feels more logical, I think. But we'll see how I do it, because I want to keep the whole reporting stuff and the timers accessible down here rather than having to extract them through some variable that contains the times. Like, that's fucking weird. So here we go. We got the whole get set, sorry, not get set, we got the get, generate, and make stages, right? And the get stage is pretty cool because now, remember how we had scenes that were organized with the level root, animate a level on, you know, static level, blah blah blah. This doesn't exist anymore. Like, these are still in here because I'm not going to delete this thing and organize it yet. I'll do that later. But like, you can pretty much have a completely freely organized scene however the fuck you want, and any object that is considered to be on the quote-unquote root, it will be picked as a root object, right? So that's pretty cool. That's really cool, because basically that means you can have any organization you want, and the hierarchy stuff only begins loosely when you create a bone. So that's great, because you can now use collections to organize the scene rather than using these weird empties which look annoying as fuck to deal with unless you make them invisible, right? So that's a win for me. Basically, we just get the root objects, which is a function that literally just gets all of the objects as the scene and iterates over them extremely quickly. Like, the get stage takes 0.0 seconds. Like, it is so insanely fast that the timer is incapable of measuring any time out of this, right? And after getting all of this data, what you do is go over them and just pick the ones that are like parent equals none, right? Like, if their parent is none, then we just pick those, and those are the root of the scene. We create a scene objects found object, which is basically a bundle of data with the found, children stuff for this current parent, which would be the meshes, the waters, the lights, blah blah blah, right? And we get a recursive call. And this one is weird. I don't like the way I did it, but I'm not going to reprogram it because it's fast. And rather than taking the root, right, and iterating over the children, we directly pass, like, the way I would have done it before would be for putting a loop in here and going for every single object in found objects, right? Then pass the parent. Rather than doing that, we just pick the children and start as if we had some kind of imaginary parent, which is none, right? Kind of weird. And a bit counterintuitive if you've done any programming intro class to algorithms, where usually you would do the thing that I just explained. But this is fast, and I'm not going to rewrite it because it's really easy to understand, actually. And the rest of the code does what I mentioned whenever we've had any recursive calls, actually. But I don't give a fuck about that right now, because this is actually like so fucking well programmed and fast that I really don't want to reprogram this thing, because Python is such a weird and fucking finicky language where I would just literally go insane trying to figure out why something broke, right? Because usually, a thing that I like about any other language is that when you compile something, you know that it's most likely going to end up looking like, right? If you're familiar with the language, especially if it's somewhat low level like C, it's still a high level language in my book, but you know what I mean. And if you're familiar with the compiler, you know exactly what it's going to turn out to be like, right? And you have a pretty good idea of where your performance is going and how things are working. In the case of Python, everything is fucking interpreted, so finding something that is fast is based around the same principles. Just do as little as possible, and saving ourselves those recursive calls and just doing one base call over all of the objects and then iterating is far faster, right? So small performance gain, but it actually makes this really fast. And what we do over this function is, iterate over every single one of them. If it's not allowed to export, we just continue the loop. So that means that any children of this object that does not allow export will get fucked and not exported. And then we check every single mesh, light, whatever, and we go appending to the found objects the waters, the lava, the nav meshes, you name it, right? And in the case that the parent is of type empty and it's a bone, right, then we go ahead and we if animation export is disabled, we just ignore it and say fuck you, we are not going to export this object, right? And in the case that we have found a bone and the export is actually enabled, right, for animated level parts, we go ahead and call recursively this function, right? And this function called recursively is going to take this new found object, like you see how we pass found object twice? What we have right here is some kind of global and quote unquote current, right? And what this means is that this place right here is where we're gonna be, like, the reason we pass global and current is because rather than having some kind of current list, this one right here, first let's ignore this one right here. This one passes the entire list of the parents where we are storing the found objects, right? This is the parent itself, and these are the objects that we are processing, right? Which are the children of this object. And this list right here is where we're going to be appending all of the information that we have found, right? You can see that the current objects, we append this information. But this is not possible to be done everywhere. Why? Because in the case of, you know, lights, it's different. Every single thing in this in magicka's code actually goes attached to its parent, right? Like all of the global static level stuff goes to some quote unquote root part of the code, and everything else, when it comes to animated level part, it's got its children particles, children parts, children meshes, whatever, you name it, everything within it. Except for lights. For some reason, lights are different, and they are referenced through some light reference storage, where basically what you store is the name of the light in the transform rather than the light itself. So I pass this global, which is the static level information, and I stored within it the light always. Like always put it within the global list, and then put it within the current list as well, right? And that way we guarantee that the actual light data will always be generated here, and the light data related to animated level parts will be here, right? And since we quit here in the case that animated level part export is disabled, any lights that are related to an animated level part will not get added to the global scope ever. So because it's actually never passed through this part of the code. So yeah, this is working just as intended and pretty nicely. And that's the reason why we got two fucking lists. And it sucks, but it is what it is, right? And then we continue recursively going through the children of these children, and it's a DFS actually, because we go to the maximum recursion depth on every single iteration. So it's not too memory friendly. It could be a problem with large indentation depth in the hierarchy tree, I suppose, but like, how deep would you have to go? Like thousands and thousands of levels of indentation. At that point is your fault, you know, because even if we use a BFS, we would have to use heap memory for that, which would make things not necessarily slower if we allocate a proper buffer at the beginning, have a good allocation strategy, which Python handles like a fucking champ actually. Lists are pretty good and well optimized, but like, you would still run out of memory. Obviously you would consume less memory, but it would be from the heap and it's slower to access, but Python is all heap anyways, so not like it matters that much, but you get the idea, right? So the generate stage, it does something pretty similar. It just goes over, we got the generate scene data, we got a really retarded internal call, which we could just copy paste things in here to be faster, but like 0.0001 seconds faster due to the overhead of the function call in Python, but whatever. And basically what we do, we take all of the found async objects as a parameter, and we go over them into iterations. So the static part, which just goes ahead and, you know, generates all of the meshes, water, lava, slides, locator, triggers, particles, collisions, blah blah blah, and it now uses these generate functions, which internally are literally just a call to a list comprehension in Python. Like, we can look at it in here, you can see that it just generates things with list comprehension, right? And returns it. So this is a stupid overhead, but it's there in case I had to change the implementation, which I actually had to do multiple times, right? But anyway, and we generate them like that, and it's faster than going with the loop we did before, even though it's exactly the same as what I showed before in the other video, because list comprehension in Python makes things faster, because it's sort of like a C-level baked for loop rather than an interpreted loop, even though the interpreted instructions for the jumps are still there, right? But that small difference can make things a bit faster, and that's good. But I think I still kill the performance with a fucking function call, which doesn't really matter if you actually have tons of objects in the list, because that small overhead is only a pain in the ass if you have to pay it for like one single object or two objects, right? But if you're exporting 1,000 objects, and the overhead is basically minimal, right? As for the animated stuff, we basically have what I mentioned before. We go over every single children in the animated parts, and we call the actual implementation, which is the recursive call, right? Um, and this one right here, what it's doing is literally just this is the actual part of the function. All of this could actually go inside of this function itself. I actually say that in this comment, right? But I did it for cleanliness because it was getting too bloated to read everything in the same place. And what it does is just that it goes ahead and it just generates all of the data the same way that this thing right here does, but for animated types, right? Most of them are actually almost the same, like liquids, locators, lavas from waters, blah blah blah. It's everything the same thing, right? But yeah, and the make stage is pretty much almost the same as before. It just got cleaned up to account for the differences in the way that the code is written now. So yeah, that's all there really is to be said now. I'm kind of tired now. I'm pretty ill. You might have heard in my voice. So um, yeah, it was pretty productive. It's faster. It's cooler. It's pretty nice. But I gotta figure out the problem with the locators and stuff. So yeah, see you later.